Hello, everybody, and welcome to the Infuse case study presentation for the utilise CISG PCMG 2020. My name is Nick Burt. I'm the Client Relationship Officer at Infuse, and I'm here to introduce the three speakers from Queen Mary University of London, University of Exeter, and King's College London, as well as cover off the aims and objectives of the presentation, which is all around how the three universities rapidly accelerated their cloud adoption in the face of the changing landscape caused by the Covid-19 pandemic. Now, don't worry about taking notes. We will be giving this slide deck out to everybody who requests it after the presentation. And if you have any questions, just forward them through to utilise, and we'll be able to go through them in the Q&A afterwards. So I'd like to start with a bit of background around the University Challenge. As we all know, COVID-19 has necessitated the acceleration of digital transformation within the higher education sector as more and more teaching is having to take place online. The majority of students now also require fast access to their online learning environment, as well as course loads, and in some cases, examinations. And in this presentation, we're going to be focusing on Moodle, which is an open source online learning environment currently used by around 60% of all universities globally. So I'd like to introduce our three speakers for the day, starting off with Richard Young, who is the Assistant Director of Solution Development at Queen Mary University of London. And next, we have Mark Sanders, who is the IT Programme Manager for the COVID-19 Response and Enhance team at the University of Exeter. And we have Jessica Roberts, who is Head of Transition and QA at King's College London. The objectives of this presentation are fourfold. The speakers will be taking you through how you can radically accelerate the cloud adoption for your Moodle systems and associated subsystems. Not only this, they will cover off how you can actually utilize load and performance testing to make your software work better, faster, and smarter. In some cases, how you can re-architect Moodle, which will allow your system to cope with much higher levels of traffic while also improving its performance. And then finally, how all three universities successfully improved their VLE systems to deliver a better student experience. And I'll hand over to Richard now.
My name is Richard Young. I'm the Assistant Director for Solutions Development at Queen Mary University, where I've been there since May 2020. So a number of points I want to highlight in terms of background to this project. Our Moodle system at Queen Mary, which we call QMUL+, has been hosted by a third party for a number of years. But we worked with them in April this year to move it into the cloud. In fact, we used Microsoft Azure because we were clearly concerned about the increased usage following the pandemic and the lockdown. But we had issues in September 2019 with QMUL+, and we were nervous that actually as the term started in September 2020, very high usage of QMUL+ might mean that the system was not stable. The fact that there was an issue in September 2019 was deeply frustrating. If it took place again in September 2020, we wouldn't be teaching, and it'd be fundamentally business critical. We couldn't take that risk. So how do we approach this? Well, we worked with Infuse, and we were looking at a number of load test scenarios. We wanted to test on our current environment, but also on our 2B environment. The 2B environment we came up with was a very ambitious one. We ended up having to make some changes to come up with an interim architecture, given the limited time we had available. We only began in August 2020. So we then ran those test scenarios against the current and the future and the 2B architecture, so we can come up with what is a reasonable go-live approach. What were the challenges in this? Well, as I said, we only started working in earnest on this in August with Infuse. That didn't give us a lot of time before term started. The platform, as I said before, is managed by a third party, and actually, therefore, all the changes we're talking about here were made by them in conjunction with ourselves and with Infuse. That made for a more complicated three-party arrangement. We ended up, because of the timing, not being able to implement all elements of the target state architecture. In particular, we planned to move from Apache to Nginx, but the integration of that with Shibboleth was challenging, and we timed out, so therefore didn't take that forward. And the final one was we didn't have any full-size test environments. So over the summer, we were conducting testing against the production environment. That itself was a challenge because that system was in use over the summer for pre-sessional teaching. And once or twice, we managed to knock over the production environment. So I wasn't very popular with our pre-sessional teachers over the summer. So we started with this model, very basic one-box model, lifting and shifting from the on-premise solution into Azure. And the risk was that wouldn't scale and wouldn't give us the right experience. So our interim step was to move to a two-box model, one VM for the web server and one VM for the database, as well as some other improvements you can see there, most notably the use of the Reddish cache, the data layer. This gave us more control over the load. So what? Well, the testing you can see here, even if you can't read the slide, indicates that the number of failed transactions for the tests was far less using the interim architecture than with the current production architecture. And the maximum response times were notably lower on the interim architecture than they were in the production architecture. So this gave us some real strong encouragement. All this was built in a more modern fashion than had previously been the case on with Azure. So we had the whole thing constructed using infrastructure as code, so we can version control it and try out different environments and different configurations. The whole thing was obviously scalable up and down, and we could therefore work out what was the optimal arrangement for us at any one point in time, enabling us to optimize costs. We also ran the tests against the target architecture, and that, as you can see there, that not only did the number of failed transactions remain very low, but the maximum response times fell further to a maximum of 40 seconds. So again, we knew we were on the right track. So what happened? It worked. We are seeing 2, 3, or 4 times as much traffic on the system as last year. At times, frankly, 10 times, but the system has been performant, no reports of slow running, no evidence of any unreliability. So we're actually delighted that the system has stood up, because we were somewhat nervous before we hit the start of term. Moodle is a legacy application. Technology is not modern, but you can use these kind of techniques and approaches and scale it effectively, and you can do this and improve your student experience and reduce your cost potentially as well. Thank you very much.
Hi, I'm Mark Sanders from the University of Exeter's IT department, also representing today my colleagues Pete Robinson, our test manager, and Ian Nicol from our Teaching, Education and Learning department, who is our business lead on the project. The project was the transformation of a learning environment in response to Covid-19. The drivers for the project started with the service degradation and interruptions we saw on the Exeter learning environment, known as ELI, which is Moodle based, when it was under high demand and high load at the start of academic year 2019-2020, so back in September 2019. In light of Covid-19, a decision was taken to bring forward and accelerate the migration of that environment from its co-sector data center hosting to a cloud hosting. That was in anticipation of the increased student demand and load profile that would occur in term 1, i.e. September 2020. The need was also foreseen to support exams being undertaken online in May, moving swiftly from basically a face-to-face written format to an online format, and then again in July and August. Beyond those exams, we could see a need for the whole student body to effectively live their academic life on ELI, as that would be their way of enriching their experience, their coursework and learning experience, under what we foresaw as the Covid-19 learning and teaching conditions at that time. The target was therefore set for the system to maintain performance with up to 5,000 users logged in and undertaking complex activities in a 30-minute period as our main benchmark of performance and capability for that solution. The approach to this with our partners Infuse and also co-sector, our platform provider and supporter of the Moodle service, were to run tests of up to 5,000 users to establish whether or not the ELI environment could handle the expected level of load and indeed beyond that. Following those tests, we did make changes to the cloud login architecture as well, moving from Shibboleth to Azure SSO. Having done that, we needed to further mimic volume models for the new academic year. A number of tests were run to mirror the expected student behaviour and check how the ELE performed and indeed SSO performed under those conditions and make further improvements. In summary, we had tests of up to 6,000 users being executed with a wide range of activities, login, quiz, download, upload, accessing modules, etc., and stress testing up to 10,000 users all logging in and starting complex activities within a 5-minute period, simulating very high volume uptake and class participation. Those completed tests were used to benchmark the new environment and tune services accordingly. In terms of challenges we faced along the way between, I would say, about April, May time, right through till mid-September. Certainly at the outset and running initial tests, it transpired that sessions were blocked for logins as soon as levels became high. And we changed this and changed settings to make sure that students or effectively test user accounts would have no issues accessing course loads and course content. We also found that certain course structures and layouts resulted in issues in terms of responsiveness and response times and download times, and they needed a bit of a rethink as well. And we had various models to take into account, synchronous, asynchronous, face-to-face online, combinations thereof, and also across multiple time zones, effectively stretching the student day from a standard UK day to about an 18-hour, 7-day-a-week day. We also encountered issues arising from previous expectations around acceptable file upload and download limits, which needed to be moderated and modified and handled, and with agreements on guidelines rolled out to the teaching community. So to the results and the outcomes, by iteratively tuning the balancing architecture, the infrastructure, and the SSO login techniques and mechanisms, we're able to reduce and pretty much negate login failures. We had much faster page download times for even larger file types. We're able to remove errors seen with logins within the co-sector login server infrastructure. And multiple tests resulted in multiple results. Highlights included Azure login server performing better, still seeing issues with large numbers, but certainly within acceptable levels. Session configuration tuned for better performance, and volume limits reached and reported, giving confidence in the system, meaning that we knew where our upper limits were at this point, and we knew how far we could go. And we could pretty much safely assess that we weren't going to reach those, or highly unlikely we would reach those, as soon as term started. And therefore, we had confidence and comfort that we would be successful during that phase. In terms of impact of changes made, and using a relatively low number, 250 concurrent users to prove these, we rebalanced the load balancing servers. That actually led to a reduction in login failures pretty quickly and a reduction of response times at all levels of load, as is illustrated by the two graphs and table. On this slide, you can quite clearly see the difference in graph shape and what the story is telling you between 21st of April and 2nd of May, and also the figures down in the table and the drop in failures from 50 to 0 and 67 to 2 for OpenSSO login and for login, which basically represented an acceptable level from a level which had caused us worry previously. We could also see that the move to the Azure cloud-based servers improved responsiveness and Active Directory logins, resulting in less login failures, even up to 4,000 concurrent users, which kind of meant that we were comfortable that we could push the system that far and was probably going to be beyond where we needed to push it. Indeed, we took it right up to 20,000. And what we learned from that was that while performance remained acceptable, even well into the 4,000 numbers, it never actually failed up to 20,000. But if you were a student trying to use the system over 10,000, say, you probably wouldn't be having a particularly good experience. But that said, we didn't expect to have to go that far as part of our rollout to live in September. One of our final, and in fact one of our headline tests, was to run 10,000 users in a 5-minute period, all logging in and starting a complex quiz in that same time frame. We discovered with that while the system could withstand that and indeed cope with those numbers, the degradation performance was somewhere over the 4,000 mark. So again, what that told us was where our limitations were and how far we could effectively push this system. So what are our key takeaways from all this? Essentially, by migrating to Azure SSO and Azure Cloud for our LE system, we were able to start term successfully. That's the main success. We had basically no reported problems relating to stability of performance in the induction week or those first 2 weeks of term, when things are very busy and very active with student numbers, a lot of concurrent activities, a lot of changes going on. And even since then, now we're in November, no reported stability performance issues on that system. So I think for that, in those terms, we've had a great success. We have great confidence in the system now, and indeed the testing we did with Infuse and co-sector leading up to that gave us confidence as we led into the start of term. So we're already fairly confident at the outset. This informs us well looking ahead. We know how to model our system. We know how to dimension our system for the various changes in the university academic year calendar relating to exams and other times of changing load. We know where our limits are as well. So we can look at our monitoring and we can see where we're getting close to where we encounter limitations during our testing phase with Infuse. And overall, the student experience is better. Systems are faster, downloads are faster, access is faster than it was under the previous system, even with the numbers that are 3 or 4 times in excess of the maximum we ever saw before this year. So that concludes the slide set from Exeter University. Thank you for listening.
Hi, my name's Jessica Roberts and I head up the QA team at King's College London. Back in March, we embarked on a Moodle cloud migration project. And these next slides will show how, working with performance test specialists from Infuse Consulting, we were able to provide a load performance testing phase to give us the information and confidence to go live with this solution. Our Moodle instance at King's we call KEATS. So what were the drivers for this project? There'd always been ongoing discussions with co-sector to migrate our KEATS instance into Azure Cloud from their current hosting solution. co-sector had confirmed that the current solution would not scale much further, and it would not be likely to accommodate any increased demand. And then with the arrival of Covid-19 and the need to react very quickly to the anticipated traffic on KEATS, our only option was then to accelerate the planned transition to the co-sector service hosted on Azure. So KEATS is absolutely essential to the university and to student learning, and my QA team were engaged to provide the testing evidence to show that the cloud migration had met the benefits, these being scalability and increased performance. So we'd also go on to have a second phase, which would be to upgrade KEATS to the latest Moodle version, which would then bring new functionality and an updated look and feel. Our testing approach was split into two phases. Phase one being to migrate the current version of our KEATS instance into the co-sector Azure cloud and then re-baseline. We previously performance tested back in July 2019 and utilised 8 business critical scenarios. And this was helpful in ensuring that we could show there'd be no degradation in performance post the migration. And during this phase, the business was actually anticipating an increase in response times of between 10 to 15%, this being an improvement on July 2019. We ran load tests, a 1-hour steady state duration, to verify response times. We also performed a stress test to determine how the application and the infrastructure behaved while slowly increasing the user load up to 3,000 users. And then finally, we ran a SOAP test, which is an endurance test, to check for memory leaks and to determine how the system performs under like sustained usage for 12 hours. This round of testing was undertaken to support our go-ahead on the new cloud infrastructure. And then testing phase 2 was undertaken to support, to focus on the functional improvements to KEATS via an upgrade to the latest version of Moodle. And here we ran 3 rounds of testing. So round 1 to determine a new baseline performance test on the upgraded environment to the full-scale UAT environment with Apache config and memory adjustments that had been made by co-sector. And this was as a result of the observations made from the last rounds of testing and also feedback from other institutions. We ran benchmark, load test, stress, and SOAP test. And then for round 2, we added in a calendar block to timeline content management and the EveAssist plugin, because these had previously been turned off due to some performance issues. For both rounds 1 and 2, we also ran additional scenarios for global search at course level, as this had been an area that required closer scrutiny due to fluctuations in response times. And then for round 3, which was our final round, and this was our built-in contingency round, where we could ensure we were running with a stable environment, any issues had been ironed out, and also we turned off global search and just reran the load test. Our main goals for phase 1 were to compare the existing baseline taken from our on-prem co-sector KEATS performance test and then compare this with a new run taken from KEATS within the Azure cloud and ensure that this met the business acceptance criteria, and this being no degradation in performance and an increase in response times of between 10 to 15%. Phase 2, we wanted to show that the upgrade and the subsequent server config settings didn't affect the performance, and then also give us a new baseline from 3.9.0. We wanted to be able to show how the system performed under stress, increasing the concurrent users to a degrade point over a longer duration of time. So the KEATS cloud migration proved that the response times observed for these chosen business critical transactions met the acceptance criteria and were also consistent across a steady state duration. In fact, the majority of transactions showed a performance increase of 70% and above. The stress test proved an improvement in application capacity. So 320 concurrent users could access the application without error, whilst previously this had only been around 200. The KEATS upgrade was benchmarked, and we can then use it for future load test comparisons. The SOAP test revealed no symptoms of memory leakage, and we were able to show the upgrade itself was stable, but also it enabled us to take the decision to turn off global search because of the response time fluctuations. So we did encounter some challenges along the way. The timescale for the initial cloud migration was incredibly tight as we were having to react very fast to meet the demands of this additional traffic. We had a delay in setting up the 3,000 user accounts, which impacted our delivery plan, and we raised a risk against the project for this. Luckily, our test consultant, Shiny, was able to react to this, and we managed this without impacting go live. In phase 2, we also encountered an issue whereby, because of this really tight timeline again, our Shiny, our test consultant, had to script before we had the full configuration of the new Lambda theme, hadn't been properly integrated into the environment, and we raised a project risk around this. We also encountered, as mentioned, fluctuations and variations in the response times for global search, and then during analysis, it was actually observed that global search was the most time-consuming transaction during the upgrade tests, and hence the decision to disable this was made. So this slide gives us an example of the information that we were presented in a very detailed report, and this enabled us to make those decisions. The final round here shows the transactions perform better than the benchmark, and you can see the variances mentioned in these fourth and fifth columns. So our key takeaways from this were, so our existing Moodle instance was hosted on a single box and unable to scale to meet increased demand. There was a high risk from the lack of proper disaster recovery. We weren't really getting any of the advantages that state-of-the-art cloud computing can provide. We were able to prove by updating our hosting to Azure, we benefited from the robust scalability and availability that this provides. And from running the various tests, we could further optimize the performance and identify any issues to prevent outages. We were able to give the confidence to the business that our KEATS instance was able to respond to growing demands, increase the quality of the student experience, and ongoing monitoring is showing us that this continues to be the case.
Thank you, Jessica, and thank you to Mark and Richard as well. We now like to open the floor up to any questions that you might have regarding the topics that have been discussed. As I mentioned previously, if you do want a copy of the slide deck, all you have to do is request it. You can do that by going to the Infuse landing page on the utilise website or emailing us directly at info@infuse.it.